In this video, we're going to do a quick recap on how to balance chemical equations. Remember that a chemical equation needs to follow the law of conservation of mass. Law of conservation of mass. And so what that means is if you have 5 grams of reactant at the end, you should also still have 5 grams, assuming you didn't spill anything or lose anything when it escaped. But ideally, nothing gets created or nothing gets destroyed. It's just rearranged and connected in different ways, so the mass should still be the same. So to convey that in our chemical equations that we write, we need to make sure that it's balanced. So here we'll have a chemical equation written out. Sodium plus some chlorine gas, Cl2, produces sodium chloride, NaCl. And what I want to point out is that when you have a chemical formula, like this, for example, Cl2, this small number over here is called the subscript. It's called the subscript. And what that means is that in Cl2, there are 2 chlorines. But then what you can also do in an equation is you can put a big number in the front. So for example, if I put 2 Cl2s, what that means is that there are 2 Cl2s there. There's Cl2 and then another Cl2, right? So you have 2 of those. That's what that big number means. And that big number is called a coefficient. So in this case, in 2 Cl2s, you have, 4 Cls. 4 Cls total, right? 2 times 2 is 4 Cls. So you do need to review how to count atoms. If you haven't already done that, please make sure you review how to count atoms in another video. So here we have to go and count how many atoms we have on the reactant side, on the left side, and on the right side, the product side. So for sodium, we have 1. For chlorine, we have 2. On the right side, for sodium, we have 1. For chlorine, we have 1. Notice it's not balanced because our chlorine is off. We need to have 2 chlorines on this side here, but we don't. So the only way to balance an equation is to change the coefficients you have in the front. When there's no coefficient, it really means 1. You cannot change the small numbers, the subscripts. You can't change these because then you change the whole substance altogether. So you can only change what's in the front. So to get 2 chlorines here, I'm going to put a 2 in the front here. And that multiplies everything by 2. So there's a 1 there, there's a 1 here. So 2 times 1, 2 times 1. So this becomes 2, this becomes 2. Now notice our chlorine is balanced because we have 2 chlorines. But notice that our sodium is no longer balanced because we have 1 on the left side, 2 on the right side. That's a nice fix, an easy fix. All we have to do is make 2 sodiums by putting a big 2 over here. And so that's 2 times 1 gives you 2. So now we have 2 sodiums, 2 sodiums, 2 chlorines, 2 chlorines. And you just jump back and forth until everything is nice and balanced, as you would see there. We'll try another example. Let's do H2O decomposes to form H2 plus O2. Always start by counting the number of atoms you have on both sides. Let's take a look at our hydrogens first. We have 2 hydrogens, and then for our oxygen we have 1, right? Because there's no number written to it, so next to it, so that means 1. On the right side we have 2 hydrogens and 2 oxygens. So comparing hydrogens on left to right, 2 and 2. That looks okay. But comparing oxygens on left to right, we have 1 and 2. We need 2 oxygens on the left side. We cannot change the subscript. We can't add a number there. We can only change the coefficient. So we'll do that. We'll put a 2 here. When we do that, that's 2 times 2, so that turns our hydrogen into 4. And then 2 times 1 over here, so that turns our oxygen into 2. So now our oxygen's okay, it's 2 and 2, but notice our hydrogen is off. We always go back and recount everything. A hydrogen on the left side, there's 4 of them now, but on the right side, there's still 2. So how do you get 4 on the right side? Well, you simply put a 2 over here. That's 2 times 2. That gives you 4. Now notice our hydrogen is 4 and 4. Our oxygen is 2 and 2. And now the equation is completely balanced. If you don't end up putting a coefficient, I usually tell my students to put a 1 there just to show that you're done balancing, because sometimes you forget. So put a 1 wherever you don't put a coefficient, because it was a 1 to begin with. It's just implied. We don't have to write it out. Let's try another example. Let's do, we'll do a synthesis. So Na2O plus CO2 produces Na2CO3. So let's go count everything. We have 2 sodiums on the left side, 2 sodiums on the right side. For carbons, we have 1 on the left, 1 on the right. So far looking so good. 2 sodiums, 1 carbon, 1 carbon. Okay, let's take a look at the oxygens. We have 1 here and 2 here. So that's a total of 3 oxygens. So don't forget that you have 3 oxygens total. You have to look at everything collectively. And here you also have 3. It looks like everything's already balanced. 2, 2, 1, 1, 3, 3. Since everything's balanced, we can go ahead and put 1, 1, and 1. Already balanced. We're good to go. We don't have to waste much time with that. Let's try an example with a single displacement, and we'll try balancing it. Let's do K plus CaNO3 produces Ca plus KNO3. And so sometimes these ones here can look a bit scary because you have these polyatomic ions in there, but I'm going to teach you a trick for this. So let's start counting. For potassium, we have 1 on the left and 1 on the right. For calcium, we have 1 on the left and 1 on the right. So it looks so good. Looks good so far. Now, nitrate, notice there's a nitrogen in there and there's oxygen in there, and you can count them individually if you want to. You can do 2 times 1, 2 times, and you can do that. What I do is I count the nitrate as a single unit, and here's why. The nitrate appears on both sides, so on the left and on the right side, unchanged. So treat them as a single unit, and your life is a lot easier. So rather than saying I have 6 oxygens and 2 nitrogens, I can say there's 2 nitrates overall. And here, since there's no bracket or there's no bracket, that means here we have 1 nitrate overall. So that means our nitrate is not balanced, as a unit is not balanced. So if I put a 2 here, that gives me 2 potassiums, and now I have 2 nitrates overall. So now my nitrate is balanced, my calcium is balanced, but my potassium is not because I have 2 on the right and 1 on the left. So all I have to do is put a 2 here. That makes this 2. So now I have 2 potassiums as well. Everything at the end is balanced. So if your polyatomic ions appear on both sides unchanged, treat them as an individual unit rather than having to count the individual atoms. It'll make your lives a lot easier. And so that was balancing equations to follow the law of conservation of mass. The only way to get really good at this is to practice and practice and practice and do different types of problems, and you'll get better and better. It's like solving a puzzle. The only other thing to mention is make sure that you write these out in their more reduced form. So for example, some students may have just done some trial and error, and they would have got this. They would have got 4K plus 2Ca NO3 2 produces 2Ca plus 4KNO3. And this is balanced. You'll notice if you count everything, it's all balanced, but notice that it's double of what the coefficients are over here. It's the double of those. And so you want to make sure you reduce these, just if you can, by dividing everything by 2. So always give me the simplest balanced form, so that way you get your 2, your 1, your 1, and your 2 here. So simplest balanced form is the best. Theoretically, this works as well, but when it comes to our calculations and to our conventions, we do like to keep things in their most reduced form, just like we would for ionic compounds, for example.